Alright, let's talk about how averages behave when we collect data repeatedly, time and time again. It's tough to picture gathering tons of data, but this is a crucial concept in statistics. Point 1. Let's make sure we're clear on what an average is. Repeat an experiment n times, add up all the results and divide by n. That's the average, plain and simple. Point 2. Now let's increase the number of trials. The average will get closer to the expected value. This is the law of large numbers. As n gets bigger, it converges. Law of large numbers. More trials bring stability. The average's variation will eventually decrease. Yes, increase, and then it's guaranteed. Point 3. Let's understand what the distribution of averages is. Repeat an experiment n times and find the average. Do this sometimes. That's the distribution of averages. Point 4. Let's increase the number of trials. The distribution of averages will approach a normal distribution. This is the central limit theorem. As n gets bigger, it converges. Central limit theorem. More trials determine the shape. Data bias will eventually disappear. Yes, increase, and then it's guaranteed. How the law of large numbers works. The variance of the distribution of averages is sigma squared over n. And as n increases, it approaches 0. So the average becomes more precise and heads towards the expected value. How the central limit theorem works. Even if the original distribution has skewed values, the number of combinations of skewed values is small. So the average is more likely to be around the expected value, where the number of combinations is high, and it approaches a normal distribution. Law of large numbers. More trials bring stability. Central limit theorem. More trials determine the shape. Yes, increasing, and it's guaranteed. So, do you get the picture? These two laws are incredibly important in statistics. Understanding them will help you analyze data more deeply. Now think about your own data.